Now friends, let us take this circuit here and let me assume that I want to find the currents, some of the currents here. So let me take the current. So this, let me call it as I1 and let me call this as I2, and naturally the current which is flowing here will be I1 minus I2. We have known all these things till now. Now how can I solve this question? Now basically how I can solve this question is I can apply two KVLs. One I can apply here and the next one I can apply here. So let's see what we get when we apply the KVL. So let me start from here. So I get 6I1 plus 3 into I1 minus I2 minus 42 equal to 0. Alright. So if I solve this, I get 9I1 minus 3I2 equal to 42. This is my first equation. Alright. Let me take the second one here. So I start in this point and I'm going to end at that point itself. So what do I get? I get 4I2 minus 10. And here see, my current and the current direction are different. So I have to put a negative sign. So minus 3 into I1 minus I2 equal to 0. So what do I get? I get minus 3I1 and this will be plus 7I2 equal to 10. Alright. So you grab your calculators and if you put this, you will get I1 to be equal to 6 amperes and I2 to be equal to 4 amperes. So this is one way of solving. In fact, if you do the method like this, you can solve any question. Alright. Personally, I also prefer this method, but just for the academic sake, we have to learn the proper mesh analysis technique. Alright, in which we are going to define mesh currents also. So let me take the same circuit once again. Let me paste it. Yeah. Alright. So what is mesh current? So I have told you in this you can identify two meshes. So this particular thing which I am, let me just put that mesh in a different color. Yeah. So this particular marking which I am doing, see this thing here, this is one mesh and this is the second mesh. Alright. So you can clearly see this mesh is a loop which does not contain any other path. So the next step is to identify mesh currents. Alright. So mesh currents, you have to put it like this. So this is the mesh current I1 inside mesh 1 and this will be the mesh current I2 inside mesh 2. Alright. You can clearly see this mesh current I1 is flowing through the 6 ohm. Alright. And the mesh current I2 is flowing through the 4 ohm. That is a good thing because elements which are not common in the two meshes have different currents, and that is an advantage for us. Alright. So let us start writing by the KVL, and there is an important thing which you have to identify when you are going to write the current through the 3 ohm resistor. So let us start at this point and let us move in the same direction as the current. See, the current is moving like this, right? Current is moving like this. Alright. So I get 6I1. Alright. Now I am entering the 3 ohm resistor. So because you have selected the first mesh and your main current is I1 here and you are moving in the downward direction, clearly the current I2 is moving the upward direction and it is opposing the mesh current I1. Therefore, the downward current direction will be I1 minus I2. So because we are moving in the same direction, the downward direction, so I can put plus 3 into I1 minus I2. I2 because I2 is having a negative value because I2 is opposing the I1. So this is one thing, and next I come here, so I reach the minus 42, so that is equal to 0. So what do I get? 9I1 minus 3I2 equal to 42. Alright, so this is my first equation. Let's take the second mesh here. So this is the first mesh, and let me put the second mesh equation. So I start here. Now clearly I2 is the mesh current and that is going to flow through the 4 ohm resistor. So it is 4 into I2 minus 10 because I am entering the negative terminal. Now look at here. I am going the same direction as current and that is in the upward direction. In the mesh 1 I was going the downward direction, but when I am following I2 I am going the upward direction. So when you are selecting I2 and you want a positive value, for the effective value should be positive, that should be in the upward direction, right? Now who is opposing I2? I1 is opposing I2. Therefore you get plus 3 into I2 minus I1 equal to 0. So what do you get here? You get minus 3I1 plus 7I2 equal to 10. This is the second equation. You can clearly see the first equation in the first method and the first equation in the mesh analysis technique are the same, and the second equation of both the methods are also same. So if you solve, you will get the same results. Alright. In fact, you can do any problem with the same technique which I have discussed here. In fact, many people use this particular method and use KVL and continue their problems. But mesh analysis also is a proven technique, and some people are comfortable with this and some people are comfortable with this. We will be doing basically with this technique because that is what followed in the books. But personally, I use this particular technique because in this I don't get confused with mesh currents and all, because always my currents are defined properly. So till the mesh analysis technique concept finishes, I will be following this method. All right. But in other circuits, when I do, I will be using this method. So it is your priority. You can select the method which you like and you can do the problems. So let us take the first problem. All right. Let us take the first problem now. In this particular question, they have already given the mesh currents and you are asked to find the value of I1 and I2. So as usual, we can start from this point. Let us take the first mesh and write a KVL around it. Now this I1 is going to flow through the 14 ohm because it is following this path and I am also moving the same direction. So it is 14 into I1. All right. Now what do I get here? These two resistors are in series. So I can just combine them and put one particular 10 ohm resistor. All right. So this current is moving downwards and I2 is opposing that. So I get plus 10 into I1 minus I2. Now I'm putting a plus sign because I am moving the same direction as the current. All right. So minus 6 equal to 0. So what do you get? 24 into I1 minus 10 into I2 equal to 6, and this becomes your first equation. So this is the first mesh. And for the second mesh, let's start from this point and let us move in this particular direction, the same direction as the current. So this is my direction. All right. I am also moving the same direction. So this I2 will be flowing through the 10 ohm resistor in the same direction in which I am moving. So it is 10 into I2. All right. Then we see the plus 5 volt. And look at here. I am entering like this and I1 is opposing me. All right. I1 is opposing me. And I2 and I1 are in opposition with each other. So I get plus 10 into, because I1 is opposing, I put minus I1. So that's equal to 0. So what do I get? I get minus 10 I1 plus 20 into I2 equal to minus 5. All right. So if I calculate using the calculator, I will get I1 to be equal to 184.210 milliamperes and I2 will be equal to minus 157.9 milliamperes. Now what does this minus sign indicate? The minus sign just indicate that we have taken the current in the wrong direction. In fact, it is not wrong, but for the positive value, the mesh current would have been the opposite direction. So let me just redraw the circuit just to clear the confusion. Yeah, this 6 and this is like this. I'm not putting the resistor values. Yeah. So the first mesh current will be 184.210 milliamperes. And if you are putting the same direction as given in the question, you will have to put a negative sign. Now, because we have got a negative sign, let me just put the current like this. All right. And this will be plus 157.9 milliamperes. All right. Now, before concluding, let me just do one more problem which has 3 meshes in it. All right. Now, till now we have done 2 meshes. Now, let us do a problem with 3 meshes. All right. Now, in this problem, you are asked to find the value of I1, I2 and I3. The meshes they itself they have identified in the problem. If they have not given, you can put your own current directions. Now, let us start from this point and let us move through the first mesh, which is this one. All right. The first mesh, let me just do it like this. So this is the first mesh. All right. So if I put the mesh equation here, so the first I am moving through the 1 ohm resistor, right? Now 1 ohm resistor is common for the mesh number 1 and mesh number 2. Because I am moving in the downward direction, I1 is my priority current. So it will be 1 into I1 minus I2 because I2 is opposing I1. All right. Now, then I am coming to the 6 volt source. So it is plus, so plus 6. Now when I move through the 2 ohm resistor, clearly I can see that the I1 and I3 are in opposition with each other. So I get plus 2 into I1 minus I3 and then I am reaching the minus 7 volt. So minus 7 equal to 0. So if I solve this, I will get I1 3 into I1 minus I2 minus 2 into I3 equal to plus 1. So this is my first equation for the first mesh. So for the second mesh, I will start from this point. I will move like this and I will come here like that. So clearly 2 is not common with any mesh. So that is the the I2 will be flowing through the 2 ohm resistor. Therefore, I will get 2 into I2. Clearly, through the 3 ohm when I am moving, I3 is opposing I2. So I get plus 3 into I2 minus I3. Alright. And when I come back here, I am moving in this direction, in the same direction as the current. I1 is opposing I2. So plus I2 minus I1 equal to 0. Alright. So if I simplify this, I will get minus I1 plus 6I2 minus 3I3 equal to 0. And this is the second equation. Let us put the third equation now for the third mesh. So this is the third mesh. All right, I'll just shade it a little bit. So this is the third mesh. So I start from here. Now remember, I3 is our main current here now. So I'm starting like this. I'm moving the same direction as I3, in the clockwise direction. All right. So I start from this point. So 3 into I3 is moving like this. I2 is opposing. So I3 minus I2. All right. Then I come through the 1 ohm resistor. So that is exclusive to the third mesh. So I1 into I3. And look at now, I'm entering like this through the 2 ohm, but I1 is opposing. So I get plus 2 into I3 minus I1. Then I enter the negative. So minus 6 equal to 0. So if I simplify this, what will I get? I will get minus 2 into I1 minus 3 I2 plus 6 I3 equal to 6. Take your calculators, plug in these values, and you will get I1 to be equal to 3 amps, I2 to be equal to 2 amps, and I3 will be equal to 3 amps. Alright. So basically in all these problems, we are just finding current or voltage values. But the question might be to find the power also. Alright. So in case somebody asks you what is the power delivered by the 7 volt. So what will you do? You know I1 value, and because the current is leaving the positive terminal, the power generated will be positive. So you put a plus sign, and 7 into 3 equal to plus 21 watts. Alright. And if you want to find the power dissipated in the 1 ohm resistor, so power dissipated in the 1 ohm resistor, which is common between 1 and 2, alright, because there are 2 1 ohm resistors, what you can do, now this current which is going to flow in the downward direction will be I1 minus I2. So I1 minus I2 whole square into 1. So I1 is 3 and I2 is 2. So whole square into 1. So it is 1 watt. So the problem might be many, but ultimately our objective is to find voltage and current. From that you can find anything else. Now, so before starting with this problem, clearly you can see that the objective is to find the current Ix. Excuse me. The important definition of mesh analysis you should recollect in this point is that mesh current is the current which passes along the perimeter of the selected mesh. Alright. Now, in this case, let us see if there are some mesh currents which are available. Alright. Let us first identify the meshes actually. So this is one mesh. Alright. This is another mesh. This is another mesh. And this is another mesh. So when you see this problem, clearly you will have a tendency to directly put the super mesh here because you are having a current source here. But it is not always the case because you need not use it always because the objective is to find Ix. So we will see that we need not use it always. Now let us mark the mesh currents now first. So that is your choice to mark the mesh current. So this is your first mesh current I1 and this is second mesh current I2 and this is the third mesh current I3. Alright, so 3 mesh currents I have selected. You can clearly see the mesh current I2 will flow through the perimeter of the second mesh, which is this one here. So that will flow through the 2 ohm. Now that is the same current which is asked, which is Ix. Ix is also the mesh current here. Therefore, the first thing which you can note here is that Ix will be equal to I2. Therefore, if you find the mesh current I2, you will be finding the value of Ix. Alright, now the next thing that you can see is that in the fourth mesh here, you can clearly see that through the perimeter, it is the 8 ampere which is flowing. Alright, 8 ampere. So this is nothing but the mesh current for this is also the mesh current for the fourth mesh. Alright, so the fourth mesh. Alright, so let us start proceeding to write the mesh equations. Let us start from this point and I am going to move in this direction. Alright, I am moving in this direction for the first mesh. So I start with the 8 ohm. So I get 8 into I1 All right. By this time, you should understand why we have put plus 8 into I1. So in case you are having doubt, you can go through the previous lectures and you can see the steps to write KVL equations. Now, in this 4 ohm, there are two mesh currents. Therefore, you will have two effects there. So it will be plus 4 into this current which is flowing I1 and I2 is opposing. So it is minus I2. And then minus 100 equal to 0. So if I simplify this, I will get 12 into I1 minus 4 into I2 equal to 100. So this is my first equation. Now for the second mesh, I can start from this point and I can move in this direction. All right, I'm going to move in this direction. So I'm starting at this point. So initially I will not take Ix, I will just take I2 itself. So this is the first mesh and this is the second mesh. All right. So I'm writing the KVL here. So it is 2 into I2 because I2 and I'm moving the same direction, plus now it is 3 into this current is I2 and I3 is opposing there, so minus I3. All right. And when I come back here, I see that there is a 4 ohm resistor, so plus 4, and I am moving in this direction. I2 is giving me a positive result, I1 is against, so minus I1 equal to 0. So if I write it in a proper manner, I will get minus 4 I1 plus 9 I2 minus 3 I3 equal to 0. So this is my second equation. Yeah, now let us try the third mesh. You have to be very careful when you are writing the third mesh here. All right. So you are starting from this point and let us move in this direction. Okay, we are going to move in this direction. Okay. So when you reach the 10 ohm resistor, all right, when you reach the 10 ohm resistor, you can clearly see there are two currents which are going to be involved. There is going to be the current 8 amperes, which is part of the mesh 4, which is going to flow like this. All right. And then you are having your I3, which is going to flow like this. All right. So clearly what you can see here, unlike the other cases where usually the mesh currents are opposite to each other, in this case, the mesh currents are together with each other. All right. So the effect of 8 ampere on 10 ohm will be a positive sign. The voltage drop there will be, I will put a positive sign. So plus 8 into 10. All right. Then the effect of the I3 is also positive as per sign conventions, plus 10 I3. All right. I hope you understand this point here. Then you get plus 5 I3. When you reach here, you are having 3 ohm resistor and you are having this I3 current and I2 is opposing. So you get the equation like this. I hope you have understood this point. This is very important. If you don't write this properly, you are going to make a mistake there. All right. So if I solve this, I will get minus 3 I3. Okay. And not sorry, I'm made a mistake here. Yeah. This is minus 3 I2. All right. And you get 10, 15 and 18. So plus 18 I3 equal to minus 80 here. In case you forgot to write this 8 into 10, you will get here 0 and you will end up getting a wrong result. So what you have to do is you have to take your calculator, you have to plug these three equations and you can find the value of I1, I2 and I3. We are interested in the value of I2 and we will be getting it as 4.65 amperes. All right. I hope you have understood this problem and the concept of this mesh current here, the effect of this mesh current. All right. So otherwise you can also write it like this. You can write the 10 into the effect of 8 and the effect of I3 is addition. So 8 plus I3. You can write this like this also. Okay. So with that we can finish this problem. This is the next problem here. In this problem you are asked to find the currents here. We are asked to find the, basically we are asked to find the mesh currents. So we can identify the meshes. So this is one mesh, this is the second mesh and this is the third mesh. Let me write the mesh currents here. So this is going to be my mesh current I1. All right. And this going to be my mesh current I2 and this is going to be my mesh current I3. All right. It's well and good now. So this is 2 volts. I forgot to write that this is 2 volts here. Yeah. Okay, let us start by writing the mesh equations. Let us start from this point. So I get the first mesh equation to be 5 into I1 plus 1 into I1. All right, then I reach here is minus 2 minus 6 equal to 0, 6 volts. So I get here I1 to be equal to 8 by 6. So I1 is directly got with the first mesh itself. You don't have to have any much complication. So this is the first mesh. So in the second mesh, when I put the equation, what I get is I have to start from this point and I'm going to move like this. So I reach the 12 ohm. So I am going to move with the direction of I2. So I get I2 minus I3 minus 15. Then here I come. So plus 3 I2 plus 2 equal to 0. All right. So yeah, we have got this equation here. For writing the third mesh here, let us just simplify this and let us put it into a better form. So it is 15 into I2, all right, minus 12 into I3 plus 0.5 equal to 0. All right. Oh, I'm a bit sorry here. I just made a mistake. This voltage, I was just thinking why I'm not getting the value. This is 1.5 volt. All right. So here you are going to get 1.5 and yeah, that's the only thing here. Yeah, there is no mistake in the first equation. Only the second equation I have written 15 volts instead of 1.5 volt. All right. So this is 1.5 volt. Okay. Yeah. Now, before writing the third mesh equation, let us see if we can just find out something directly from here. All right. You can clearly see I3 is the mesh current and so is 0.1 Vx. 0.1 Vx is a dependent current source. All right. So I3 is the current through the mesh and 0.1 Vx also is the current through the perimeter. So I3 is equal to 0.1 Vx. Now what is Vx equal to? Based on this particular polarity and this particular current I1, Vx will be equal to I1 into 1. And I1 we have already found it to be 8 by 6 into 8 by 6. So Vx is equal to 8 by 6 into 1, which is equal to 8 by 6 volt. So if I substitute that here, I will get, if I substitute this value here, I get 0.1 into 8 by 6. And if I take this and I substitute it here, I'll get 15 I2 minus 12 into 0.1 multiplied by 8 by 6 plus 0.5 equal to 0. From this I can directly find the value of I2, which will be equal to 73.33 milliamps. Just note the current, it is milliamps. All right. And if you want to find the value of I3, I3 is nothing but 0.1 Vx. So it is equal to 0.1 into 8 by 6 amperes. All right. I hope you have understood the problem and I hope that the concept of mesh analysis is really embedded inside your mind